all, and welcome to chemistry. One of the first questions students generally have is, before they sign up for the course or when they walk into the room, what is chemistry? A lot of students automatically think chemistry, woo, fire and blowing things up, which could occur, but that's not all of chemistry. The textbook definition, chemistry, as you can see here, the science that investigates and explains the structure and properties of matter. And we've already had a little bit of experience with this with our nail and copper sulfate. We saw the nail, and we saw some of the changes that it went through when in the presence of the copper sulfate solution. But there are lots and lots and lots of other aspects to chemistry, which, we're going to explore some of them in this course over the year. Chemistry studies matter. What's matter? Well, to use layman's term, matter is the stuff that everything is made of. And chemistry studies that. The textbook definition of matter is anything that has mass and takes up space or has volume. But that definition gets a little tricky when you look at the definition of mass, because the definition of mass says it's the amount of matter that an object has. So they're kind of circular. Again, to me, keeping it simple, boiling it down, matter is the stuff that everything is made of. Sometimes the stuff is heavy, it's got a lot of matter, a lot of mass, and sometimes the stuff is lighter, doesn't have much matter, doesn't have much mass. And we're going to discover later in the course how we talk about these things more scientifically. But right now, just kind of keep that kind of thought in your head. So the question is, well, what is not matter? What is not stuff that makes up the universe? Well, I said keep that thought in your head. Well, thoughts, they don't have any real weight. I mean, you may be weighted down by your thoughts, but they don't have physical weight. They don't take up physical space, so they're not considered matter. Your whole consciousness is not considered matter, although some of us think, again, we have the weight of the world on our shoulders. And right now, that's a concern. But in terms of chemistry, not matter. Other things that are not matter. Well, let me pause. Take a second. What do you think is not matter? You come up with something? All right. Two more things, but actually one thing. Light. When you have a dark room and you put on a light, the saying goes, light fills the room. That it takes up space, but it actually doesn't take up physical space, and definitely does not have any mass. There's no weight to light. The other thing that is not matter, heat. Now, heat and light are related. They are both forms of energy. So we have two major classifications of stuff or things in the universe. We have matter. That's the stuff, and I misspoke earlier. We have energy. It is these two things in some combination, in some way, that make up the entirety of everything, as far as we know. Some misconceptions about what is matter and what is not matter. Did anybody say air earlier? A lot of people think, well, air fills a room but doesn't have any weight. Oh, well, if I turn on this fan, and if you were here and I aimed it at you, would you feel the breeze? You would. Air is made of matter. It's made of all kinds of wonderful molecules and atoms, and one of those is oxygen, which is very necessary for us to breathe and to exist. Over the course, we will obviously make further distinctions on types of matter, classifying matter, and we don't get into a lot of energy in this course, but it will be mentioned. When we describe matter, which we're going to do a lot, we're going to describe matter's properties. What does the matter look like? What does it feel like? What does it possibly smell like? How does it act? Does it melt? Does it bend? Does it break? Does it catch on fire? Does it rust? These are the properties of matter. What does the matter look like, feel like, and what is the matter's behaviors? Now, when we discuss properties, there are two major types of properties, quantitative and qualitative. Quantitative, quantity, number. A quantitative property is a property that can be measured directly with an instrument. We had the nail earlier, and if I take a ruler, I can measure the length of a nail and come up with a quantitative measurement. A qualitative measurement, it's shiny. How can I describe shiny by a number? It's kind of gray silver, which is a color. It's kind of on the heavier side, which I could say is a qualitative analysis. If I were to put this onto a scale or a balance, I could actually get how many grams the nail was, and then that would be a quantitative analysis, or quantitative measurement, I'm sorry. And when we look at matter and mass and the properties, it's a matter of perspective. How are we looking at things? To what level are we zooming in on things? I'm going to use an analogy here. I'm a human being. You see my macroscopic, or you have right now a macroscopic view of me. If we zoom in, think biology class. Zoom in with a microscope, you're going to see the microscopic level. No longer am I going to have this big shape and form, but eventually if you keep zooming down, you're going to get to my individual cells. Now it's the individual cells and their arrangement that make up me in total. But if you look at any individual cell, and you're at that level, you might not be able to look at the bigger picture. And then if you take that cell and you zoom in more and more and more and more, if you keep zooming in, eventually you get down to the atomic level, the world of atoms, which is so extremely small that it's almost unimaginable, very abstract. As a matter of fact, most people don't believe that that's even, atoms aren't really even matter because they're so small, but they are matter. And again, through this course, we're going to explore very fully atoms at that subatomic level or submicroscopic level. Now, we can't, in this classroom, we can't actually see little individual atoms. We can't play with little individual atoms. Now, if we were in a if we had a very high-powered microscope, an electron tunneling microscope, we might be able to get images of individual atoms. But in our experience, we're not going to be able to do that. So what we have to do, in our case, is model. And what I'm going to do is model a lot of that submicroscopic world. A model is a device that lets us further understand a situation, even though it's not the actual situation. For instance, in my little beaker here, I have salt, table salt. Makes your fries delicious. Just a gritty white material, crystals. If you were to put these under the microscope, they'd look like little ice crystals, kind of, actually little square or cubic crystals. And if you were to zoom in even more, you would see the individual sodium and chlorine atoms. Now, I can't show you individual sodium and chlorine atoms, but what I can do is show you a model of those and how these atoms all link together. Now, this is obviously a very simplistic view of how these atoms link together. It does not show you the electrons and the nucleus and how they're all interacting. But this model gets you an idea of how they're interacting so you can further understand what's going on. This is just a very basic overview, and we are going to delve into these topics and concepts a lot more over the course of the year. So if you have any questions, feel free to get back to me, email, and thank you for your time.